Hi, I'm Anna Hoffman, and welcome to this Learn Live session here at Microsoft Build. I am a product manager on the databases engineering team, and I'm joined by Silvano. Silvano, why don't you introduce yourself?
Hello, good morning, good afternoon, good evening, depending on where you are. My name is Silvano. I'm also a program manager in the Azure SQL team, and I've been working on a number of IoT projects with SQL, with Azure SQL Database, and this is where most of the content that we are presenting is originating from.
Yeah, it's awesome to have you here today, and we're going to be talking about deploying IoT solutions with Azure SQL Database. And fun little backstory to this module, Silvano has built this great scalable solution to use with customers, and we kind of partnered up to figure out how we could share it with you all so you can try it for free and use it in your scenarios. So with all that being said, Silvano, can you tell us a little bit what you're hoping people will walk away from today with?
Yeah, you just said it right. So we have been kind of aggregating a lot of content and learnings that we had working with customers, and we created this module with the goal of sharing with our customers and let them learn how they can easily reuse the templates, the code, the database, in order to familiarize with the problem space and potentially to build their own solutions on top of that, right? So that they can, start being productive in the IoT space using Azure SQL Database as quickly as possible.
Awesome. Yeah. And before we get into the actual content, I do want to call out that this is live and interactive. We are joining you at home at the current time at present. So please ask your questions as you have them. We have some wonderful members of our team standing by to answer questions on the chat. So use the chat wherever you're joining from. And also some of those questions we'll put up on the screen. Also, you'll see down below, floating along the bottom is the URL to this Learn module. So if you want to follow along now or sometime next week or next month or whatever, it's going to be there for you to get hands-on for free. And with all that, oh, the one other thing I wanted to mention is at the very end, we know this is Microsoft Build, and there's a lot of announcements in the Azure SQL space. We're going to be sharing all those announcements in case you missed them throughout today. So you want to stay for the end because that's how you're going to get all the latest announcements. So with that, let's get right into it. And for this module is like a lot of modules you've probably seen before. There's always a scenario. So this scenario is, suppose you work for a distributor where your role is to manage the logistics of shipping goods between the main warehouses. Now, these goods are shipped between a fleet of several thousand trucks. So your job is to make sure everything arrives on time and all the maintenance of these trucks is done properly so that there's no delays or issues with shipments. So basically, you want to implement an IoT solution or IoT system so you can monitor all these trucks and kind of have alerts when anything is going wrong. So that's kind of the scenario, but there's a lot of different IoT scenarios that this would also apply to. And I think the next best thing to do is to lean on your expertise, Silvano, and tell us a little bit more about like a typical IoT solution, and then how that kind of relates when we move towards using like the Microsoft suite.
Yeah, and by the way, just to come back for a second to that scenario, that is actually very, very realistic because we are just getting out of this pandemic, and part of the various solutions that have been created to manage problems like, for example, how to ship COVID-19 vaccines around the world with some controlled temperature in the transportation systems and so on, were actually built using the same exact approach and architecture. And some of them were actually built on top of Azure SQL Database as well, right? So this is the canonical architecture that an IoT solution generally has. So we start from a bunch of sensors and edge devices, right, that are deployed everywhere. Can be on kind of some mobile devices, can be intelligent sensors in a factory floor, and those intelligent devices are usually communicating back to a cloud gateway. And the cloud gateway, which is typically supporting a bunch of these common protocols like AMQP, MQTT, and is managing security communications with secure communications with those devices, device registrations, and so on, are basically acting like the entry point of our cloud solution that is ingesting these IoT data. And most of those cloud gateways are also queuing up all those messages coming from those intelligent devices in the field. And we are talking about potentially hundreds of thousands, if not millions, of devices that are basically ingesting every few seconds some kind of telemetry messages, some interesting data points that we want to capture. In our infrastructure, what we typically are doing with those events, we may want to stream those events out of those queues that the cloud gateway is generally managing for what we call kind of warm or hot path, where basically we need to have a low latency processing type on those events that are coming in order to respond quickly to certain events that are happening. But at the same time, we may want to store those events in a fast and kind of low latency warm storage that can be queryable by some dashboarding or reporting applications. And again, in a faster respondent manner, some kind of users or humans are basically consuming those data points in the fastest way possible. At the same time, we may have some kind of high latency batch processing workflows that are taking those events, are storing them into kind of long-term, cheap, cold storage, and those are the ones that will be kind of feeding some analytical processes, big data type of processing, or machine learning models that needs to be trained out of those data points. Right. So those are kind of the building blocks that pretty much every IoT solution is showing in the field.
Yeah, it definitely makes a ton of sense. Thank you, Silvano, for kind of sharing with us how this works. Now, if we were to say, okay, let's use Azure for this, right? How do we translate the typical IoT solution to Azure?
Yeah, absolutely. So in Azure, we actually have a bunch of PaaS services. In most cases, those are also serverless services. So you don't have to deal with a lot of infrastructure knobs and components, and you can actually focus on the application logic, on the solution logic. We do have some great components for each of the roles that I mentioned previously. For those intelligent devices that are sitting in the field, there may be some kind of aggregators or industrial PCs, that kind of intelligent devices where we are running IoT Edge as a way to stay in touch with those local sensors deployed in the field, and also run some intelligence over there. Like, for example, there may be some kind of real-time alarming or alerting solutions that needs to happen as close as possible to where the process is actually happening, right? But generally speaking, those IoT edge devices are then communicating back with our own cloud gateway solution in Azure, which is IoT Hub. IoT Hub is dealing with those edge devices, those intelligent sensors in the field, and is managing all the protocols and communications. But at the same time, IoT Hub is also providing this event store, this queuing capability for telemetry messages coming and going to the field that we can access through, for example, Stream Analytics instance. Stream Analytics is our stream processing service, fully PaaS, fully serverless stream processing service in Azure. At the same time, we also have Azure Functions as a serverless kind of function platform that can be triggered by the presence of new events or messages in our cloud gateway, and then can execute some processing and feed the data into Azure SQL. We think that Azure SQL is a great candidate for this warm path store because it's a great combination of kind of low latency analytical capabilities in querying those event data that we are ingesting, and at the same time is also providing a simple way of deploying and managing a fully PaaS and serverless database service as we have right now in Azure SQL. There are some additional components, like, for example, Azure Blob Storage, that are instead great candidate, for example, hosting our cold path data store, because it's very cheap. It can, basically host infinite, volumes of events data up to hundreds of terabytes, and then we have some specific services, like, for example, Azure Machine Learning, in order to deal with, build those predictive models and use those cold path data to train those models, and then to run predictions on several factors in our application, right? So we do have this bunch of PaaS services that fits perfectly with a canonical IoT solution in Azure.
Yeah, I think it's a great point to highlight. Like, if you're a developer today and you want to go build an IoT solution, any one of those components that you see would take a lot of development work. So the great thing about using these Azure PaaS services is that, kind of all the hard stuff is done, and you can just focus on the logic that you want to do and how you want to analyze that data. So I think that's a great point. There's a lot of different database choices out there. We could spend the whole hour just talking about them, but could you tell us, Silvana, a little bit more about why Azure SQL Database?
Yeah, and again, with Azure SQL Database, we have, in our opinion, the kind of the sweet spot, the perfect combination of again, simplicity in terms of deploying and setting up a warm path store. But at the same time, we have the ability to actually scale up significantly, up to 128 vCores in our business critical M series hardware, or up to 100 terabytes with Azure SQL Hyperscale. So basically, we are not constrained in terms of scaling up both kind of processing power or, for example, data volume, which are the two kind of dimensions that usually a warm path storage needs to have. With Azure SQL Database, we also have the ability to push a lot of kind of data in with relatively low latency, right? So this means that Azure SQL Database, which is actually leveraging the SQL Server engine behind the scenes, have native bulk loading capabilities. Right? So this means that we don't have to insert event by event into our database tables, but we can actually bulk load tens of thousands of those events that we are capturing from our IoT device fleets directly into Azure SQL Database as a single operation, right? This is not common across, for example, a number of NoSQL data stores that rarely have the ability to run this bulk operations, right? So they are designed to insert kind of singleton operations, and this can impact, the ability to, again, ingest at low latency across a bunch of number of, source devices. With Azure SQL Database, we have this ability to scale read-only replicas, right, up to 30 named replica on Azure SQL Hyperscale, and fuel all those analytical applications that just need to query the data that we have been ingesting with from those devices. And an important characteristic is that data are already available in our Azure SQL Database few milliseconds after those have been inserted. If you think about a big data, classic kind of big data scenario, you typically are landing those events into like a cold storage, like, for example, Azure Blob Storage, and then you have a distributed processing engine, could be Spark, could be Hadoop or whatever, that is basically crunching a lot of those events and producing some kind of analytical results. Well, the latency in that scenario is typically up to seconds, right? If not more. So if we want to query the data as soon as they have landed into our warm path store, Azure SQL Database is actually a great solution. And we do have some technologies like, for example, in-memory optimized tables and clustered column store indexes that can help us to implement, to optimize the ingestion process on one hand, and storing and analyzing the data, like for example in the case of the clustered column store, in a compressed form, so that our analytical queries can go faster.
Awesome. Cool. So yeah, it makes sense why we're saying like you should use Azure SQL Database. Before we get into the first exercise and the first demo, I wanted to tell you all a little bit about the recipe or the solution that we've kind of put together for you all to get hands-on with. So basically, as part of the scenario, you're going to deploy and configure a baseline IoT solution. And then we're going to go through some of the steps where you can kind of see what types of things you can do, see how you can optimize. And Silvana's going to tell us a lot more about the shock absorber pattern. But if you take a look at this, this is a very simple architecture for how we've organized the template. You have an Azure VM. This VM is going to be using containers to kind of simulate all the devices. So you'll want to replace this with your actual IoT devices if that's the way you decide to take this. We'll use azure-iot-hub. We'll also use Azure Functions. And we're going to use Azure SQL Database Hyperscale for this one. And then we'll kind of surface all of that up into a Power BI report. So that being said, let's go ahead and take a look at the exercise in the module. So again, everything you see in this part of the demo or exercise or whatnot is going to be related to what you can actually do today online for free. So in this, what you're going to see is how to deploy the ARM template, how to deploy the schema to Azure SQL Database, how to configure the app for the IoT function. It's basically going to bring the data into Azure SQL Database, how to configure the Azure function using GitHub Actions, and start the simulator. So let's go ahead and take a look. So I'm going to go over to this screen and just show you all what the Learn module looks like. So when you go to the link, this is what you're going to see. So you see there's some sections where you can read more about the architecture, which Silvano just explained. And then there's 2 exercises that we're going to look at. Now, if you haven't used Learn before, one of the greatest things is that there's this free sandbox. So you don't really need anything, no credit card, no nothing. You can activate a sandbox. This one's for 2 hours. So you can see I've already activated it, and I can have up to 20 in a day. So this is a great way to get hands-on for free. So what I've done is I've kind of gone ahead and set up a couple things, but I just want to show you briefly how we do that. So basically the first thing that you're going to do is deploy this ARM template. And you're going to see this is all the things that you need in order to deploy the ARM template. So you can see it's going to deploy an IoT hub, an Azure SQL Server, an IoT function, like a function with the name IoT in it, a VM we talked about for the device simulator. We're also going to use log-analytics to monitor what's going on, a storage account. So everything you need is really going to be deployed for you. So that's something to keep in mind. Then we're going to do a couple setup things like the firewall rules so that your Azure SQL database can be accessed by you as well as by the Azure function. And then we're going to grab the information for the Azure virtual machine you're going to use. This takes about 5 to 10 minutes to complete. That's why we didn't do it live here, because that would be potentially a little bit boring. Now, the next thing you do once you have all those resources deployed, we can actually take a look at all the resources that get deployed by this template right here. So if we head into here, and you can also see here that I'm connecting to the Microsoft Learn Sandbox, so everything I do here is free. Now, if I go into that resource group, I'm going to see all the resources that were deployed by this ARM template. So you can see all those things I just listed are also deployed here. So it makes it really easy to get started. Now, once we have that, the next thing you want to do is deploy the schema to the Azure SQL database. And we've prepared a script for you in the GitHub repository. So basically here you're just referencing that script to deploy the schema to the database. So basically we know where the data is going to land in the database. And then the next thing you're going to do is set up the IoT function. So again, went ahead and did this, but just so you have an idea, this is the Azure function. And basically what we did is we set up all the connection strings so that everything can talk to each other. So the storage account, the SQL database, IoT-hub, all those things can connect to each other. And then once we have that, we use GitHub Actions. So this is the code repository. Let me just make this a little bit bigger so you guys can see. This is the code repository, so you'll want to fork it. This is out on the public web. And then you'll have all the code, including the ARM template, the SQL schema, the Power BI report, all that stuff is going to be here. And what you can actually do is you can use GitHub Actions to essentially supply essentially what's a connection string to your Azure function. And then you can use the Azure function action in GitHub to basically deploy all the code to that empty Azure function. So again, we went ahead and did this, but you can see how this kind of takes care of our CI/CD for us. Things like GitHub Actions are also available for Azure SQL Database. So you could do the same process and implement full, CI/CD with your database as well.
Yeah, and just a couple of
yeah.
very quick comments from my side. There are a couple of areas like for example, the one that you just mentioned on how to deploy the database schema that we could improve here. The other comment was that the reason why we were originally using a VM here to simulate, the tens of thousands of devices was because at the time Azure Container Apps was not really available. So that's one another improvement that we can have to completely eliminate any kind of IIS reminiscence from this template, right? But the idea essentially was to keep the kind of service deployment on one hand, so Azure SQL Database, Azure Functions, IoT-hub, and so on, and then the application deployment on a more like kind of manual fashion here, and those are the steps that Anna is going through right now.
Exactly. Yeah. So all that being said, the next thing you do is you connect to that virtual machine you deploy. We're going to install Docker and set up these containers. So there's basically these container images you can use that help you do Azure IoT simulating. So the first one is creating 1,000 devices. And then the second one is actually going to, do the simulation, reporting out the different pieces of information for each device. So what I'm going to do is I'm just going to go ahead and kick that one off. And immediately what you'll start to see is the messages are just flowing in. So Vani, you want to take a second to explain what these messages represent?
Yeah, absolutely. So those are, of course, JSON fragments with some variables in it that are simulating some kind of real-world metrics like temperature and pressure and so on. And what the simulator here is doing is basically taking our JSON fragment and just generating random values for those dimensions that once they will be landing into Azure SQL Database, we will use to query and to build our own dashboards and charts, right, where we are plotting the data points.
Yeah, exactly. And there's a couple ways you can log the things that are going on. First, you can check the Azure functions and check the logs. Once this gets connected, you'll start to see kind of the log of what's happening and the JSON data being sent. So for example, you can see the different simulator, the temperature, the time, the counter, if the engine's on, some different pieces of information that are being brought through. The other thing you can do, because remember this Azure function is bringing the data into Azure SQL Database, is you can look at the database itself. So here I'm connecting to the Azure SQL Database using the query editor. So this is all in the portal. And I can basically select the top 1,000 rows and see indeed we have lots of information. Let's see if I can give a little more screen real estate here, but you see we have a lot of that information, and here's the JSON information that Silvano was talking about. And I think that's it. So now I'm going to leave this running. We'll take a look a little bit later in the Power BI report, but I think it's a great opportunity for a knowledge check. Maybe folks didn't know they were going to get some questions today, but they are. So if you see this on your screen, go ahead and vote. You have two ways to do that. You can either use your phone and scan the QR code, or you can go to aka.ms/polls-h. The poll should be open, and what we'll do is we'll give you a couple moments to answer this question or share any other questions that you might have in the chat, and then we'll go over the answer. So the question, just so everyone's on the same page, is in a typical IoT solution, what is the purpose of the warm storage? So this was that very beginning when Silvano was talking about a canonical IoT solution. So think about what the purpose of the warm storage is. So go ahead and get your answers in. We'll take a look at what those answers might be. Looks like the answers are starting to flow in.
Yeah, just as a kind of a helper here, we know kind of large data volumes on cheaper storage is typically not something related to the warm path, because in the warm path you actually want to have low latency for sure, and the ability to query as soon as possible your data points once they landed, right? So you can have a glimpse on which one of these answers is actually correct.
Yeah, I think that's a helpful tip. It looks like folks are starting to answer. Folks who have answered, you might want to think a little bit deeper about what we said about warm storage. I see some of you are getting this right, and some will help you out in just a moment. Maybe what we can do, Silvana, what if we do some process of elimination? You think you can help slowly narrow down the choices, and we'll get to the answer?
Yeah, so again, I just said, probably not A, because again, costs and large volumes, reduced cost and large volumes are typically, more related to the cold, to a cold storage. Real-time streaming, that's more an area for, as we said, Azure Stream Analytics and performing some kind of real-time analysis on the fly. So B is probably not the case. For sure, we know D is definitely not the right answer, because managing bidirectional communication with devices, that's more like a role for IoT-hub, right? So the one remaining is C, which is likely the right answer here.
Yep, exactly. Yeah, so the warm storage is to persist those low latency events and messages that need to be ingested at a high rate. And for the warm storage, correct me if I'm wrong, but we're suggesting Azure SQL Database to be the solution for that, right?
Correct. That is correct.
Awesome. And it looks like about 40% of you all got that. So well done. If you didn't get it this time, there is more knowledge checks throughout this. So pay attention, and we'll get to this. Now we're going to explore something really cool, actually. Learned a ton from Silvano when we learned about how to do this really efficiently at scale. So Silvano, why don't you take us through it?
Yeah, absolutely. And again, we mentioned that we think Azure SQL Database is the right solution for this warm path requirements. And again, one common pattern that we have seen across a bunch of customer projects is this idea of having like a shock absorber in front of our kind of database tables. So basically, the ability to take sensor data generated from our IoT devices and to kind of load them into memory optimized tables as a way to kind of reduce concurrency and congestion in inserting these data points into kind of memory optimized table that are also strong, kind of significantly reducing the latency of inserting these data points. But because memory is, of course, a very kind of constrained resource, and in Azure SQL Database, we do have a proportional amount of